We'll continue our discussion of variation. We'll look at the empirical rule and intervals representing 1, 2, and 3 standard deviations of the mean. Here's an example, and we're looking at population here, where standard deviation is sigma and mu is 15. These are IQ scores. Okay, when we say distributed normally, we mean that the population has a bell-shaped distribution. And a random sample will have a histogram that looks approximately bell-shaped. So here we have 100 scores and a histogram. They're centered around 100 with standard deviation of 15. That tells us how spread out the data is. And then the population distribution is the smooth red curve. Okay, so we use the terms bell-shaped, Gaussian, and normal all interchangeably. So since the standard deviation is 15, we say a distance of 15 away from the mean of 100 will be one standard deviation. So we can go 15 on either side of 100. One standard deviation of the mean. So that interval is from 85 to 115. So any number in between 85 and 115 will be said to be one standard deviation away. So 89 and 107 are both within one standard deviation, but a score of 70 does not lie within one standard deviation. Okay, similarly, you can look at intervals of 2 and 3 standard deviations. Okay, mu plus or minus 2 sigma, mu plus or minus 3 sigma. Okay, so for example, with 2 standard deviations, you're going to go from 70 to 130. So that's plus or minus 30. Here's a sample of 50 ball bearing diameters in millimeters. You can see the mean and the standard deviation are given. We can compute intervals representing one standard deviation simply by subtracting s and getting the lower limit, and then we can add s to get the upper limit. So we get an interval representing one standard deviation. So any number falling in that range will be said to lie in one standard deviation. We can do the same thing with 2 standard deviations. We can figure out what 2s is and then add it and subtract it to x bar and get the upper and lower limits of an interval representing 2 standard deviations from 16.02 to 23.14. Similarly, for 3 standard deviations, we subtract and add 3 times s to x bar and get an interval representing. So the empirical rule tells us about how much of the data we can expect to lie within 1, 2, and 3 standard deviations. So the rule goes like this. We can expect about 68% of the data to lie within 1 standard deviation, okay, and about 95% within 2, and almost all the data, 99.7%, within 3 standard deviations of the mean. Let's see how this works out with our example. So here we have our intervals representing 1, 2, and 3 standard deviations of the mean. So I've highlighted in red all the values that lie within 1 standard deviation here. And it turns out that there are 35 out of 50 of those, or about 70%. So that roughly agrees with our empirical rule of 68%, right? So it's a rule of thumb. It's not a hard and fast, it's an approximation. If you have a sample, it'll be approximate. If your population is distributed approximately normally, it'll be approximate. So we get about 70%. Well, we get exactly 70% of the data here, which is close. All right, what about 2 standard deviations? Well, we're going to pick up these values here. Okay, and then we're also going to pick up, we get 48 out of 50, or it equals 98%. Does that agree with our empirical rule? Well, the empirical rule says about 95%. Okay, so 98% approximately agrees. So, and now for 3 standard deviations, we're going to take up all the data. So we get 100% of the data to fall within 3 standard deviations, which again roughly agrees with our empirical rule of 99.7.